Okay? So, good day everyone. So, this is our part 2 or the continuation of our module 2.2 wherein we will discuss the standard normal distribution and other such things as like exponential distribution and other topics. Okay? So the standard normal distribution is a special case of the normal distribution. It is a distribution that occurs when a normal random variable has a mean of 0 and a standard deviation of 1. Okay. So if a standard, okay, or I mean, if a normal distribution or normal random variable, okay, has a mean of 0, okay, so we have mu is equal to 0, and a standard deviation of 1, wherein our small sigma is equal to 1. Wherein, in the standard normal deviation or normal distribution, we will study or we will discuss mainly in what? In z-scores. Okay? Wherein, in z-scores, we have this called as the table that we will use in determining a certain probability of z-scores. So, table rows show the whole number and the tens place of the z-score. Okay? Remember that? Table columns show the hundredths place. So, here's an example of a standard normal cumulative probability table wherein we can determine or we can use this table in order for us to determine the z-scores or the probability of our z-values. Okay? So, based on the slide here, so it is said that the table rows, okay, show the whole number and the tens place of the z-scores, okay? So, we have here the whole numbers. So, we have here 0, 0 to 0, 0.09. And the column shows the hundredth place, okay? So, here's the row and the columns, okay? So, later on, we will solve a certain problem using the table, okay? And also, we will use a certain shortcut by using the calculator. So, in order for us not to waste our time in searching for the value based on this table, so I will discuss or I will demo a certain method in order for us to make our work worthwhile. Or we can lessen the time that we need to solve in order for us to finish the problem or the exam in time. Okay, on time. So here's the z table that I said. So let's have an example here. So we will solve a certain example in terms of the traditional way. So what is the traditional way? The traditional way is we need to look for the values based on the table. Okay? And the second method is to use the calculator. Okay? So in order for us to use the calculator, later on I will discuss it and I will have a demo on it. Okay? So we have example number 1 here. So using the cumulative probabilities for a standard normal random variable table provided. So here's the table provided. So determine the probabilities of the following. So A is probability of Z is greater than 1.26. Letter B, probability of Z is less than negative 0.86. Letter C, we have probability of Z is greater than negative 1.37. And lastly, we have probability of Z is greater than 1.25 but less than greater than negative 1.25, I mean, but less than 0.37. Okay? Like I said earlier, we will solve this problem in two ways, okay? So the first one is a traditional one wherein we will search for the values based on the table given. So we have this table, okay? And the second method is we will solve this problem by using the calculator techniques that I will show later on, okay? So for the solution number A, okay, so we need to find the probability of Z, okay, that is greater than 1.26. Therefore, however, we need the probability when Z is greater than 1.26, which is the area shaded in red on the graph. Therefore, we need to what? So like I said last time, the total value of the curve or the total area of the curve is equal to 1. Okay? Based on our part 1. So in order for us to solve for the red graph, we need to what? Subtract the value of the 1.26 in the Z table. So, here's the traditional way on how we will solve this problem. Okay. So, we have a given of 1.26. Okay. So, remember this. So, we have 1.26. So, we will go back to the Z-score table. Okay. So, based on the table, okay, so look for what is the value of 1.26. Okay. So, let's look in the table closely. So, we have here 1.2. Okay. So, in order for us to get the value of 1.26, we will look for the 0.6 or 0.06 because if we have 1.2 plus 0.06, we have 1.26. Therefore, we will search for the value that interacts with 1.2 and 0.06. So, what is the value? If we have 1.2 here, so let's have 0, 0.1, 0.02, 0.03, 0.04, 0.05, 0.06. So, the value of positive 1.26 is we have, okay, is we have 0.8962. Okay? So, based on the problem, it is correct that the value of 1.26 in terms of positive is equal to 0.8962. But they said in the problem, okay, the probability of Z is greater than 1.26. Therefore, it is what? The red region. Wherein, we need to what? Minus the value of 1, okay, to the value of our 1.26 or the probability value of 1.26 based on the z-scores. Okay? So we have 1 minus 0.8962. We have an answer of 0.1038. Okay? So that's how we solve a certain problem, okay, based on the traditional way wherein we will search for the values based on the table. Okay? So next we will discuss the method that we can use by using our calculator. Okay. So, let's have a calculator. Okay. So, let's solve for the... Okay. So, let's reset the calculator. Okay. For example, your calculator is in degree and composition mode. Okay. So, the first step is we need to what? We need to change our mode into stat. Okay. So, how to do that? So, just click the mode, then 3 for the stat. Okay. Okay, so if it showed like that, just click or press off. Then, to make sure that your calculator in stat mode or statistics mode, okay, there is an icon that is present here. So we have stat. I don't know in other calculators it is S or something, but in this type of calculator, it is stat. Okay, always remember, in terms of solving problems under standard normal distribution or majorly in z-scores, we are using a stat function or stat mode in our calculator. Okay, again, use stat mode in the calculator. Okay, okay, so in order for us to solve for the problem, okay, so we have shift. Okay, first of all, your calculator should be in stat mode. So you have shift. So if the S appeared here, so click 1. Then we have 5. Okay, then click 1 or the P parenthesis. Okay, so it is the probability. Okay, so next step is do what? Enter the value. For example, you have 1.26. Okay, so automatic, it will show the value without using the table given. Okay, so it's more important to use this calculator technique because we can lessen the time that we need to consume in solving a certain problem under this lesson. Okay, so remember, first you need to change your mode into stat. Okay, then after that, shift 1, then stat, then 5, distribution, 1 for probability. Okay, next. So, for the number letter B, So we excuse me. So we need to solve for the probability of z, okay, is less than negative 0.86. Okay. So based on the negative z-score table, so the probability of z is equal to negative 0.86 is 0.1941, which is the area shaded in green on the graph. Thus, it is the direct value because it is the green value here. Because it is what? Less than. Okay? So, let's look for the table. Okay? So, let's look in the table. So, like I said earlier, we have two methods in solving this problem. The traditional one, or the traditional way of looking in the z-table, and the other one is using the calculator. So let's use first the traditional one. So let's look for the z-table. So we have negative 0.86. Okay, so let's start here in this table. Negative 0.86. Okay. Okay. So we have here negative. Okay. So we have 0.8 here, and we have zero point 0.6. So we have 0.0, 0.01, 0.02, 0.03, 0.04, 0.05, 0.06. So we have 0.8051. Okay. Wait lang. Negative values. Okay, so let's just use the second method for this type of problem because our z-table is not complete. Okay, so let's have here for the calculator. Okay, so let's just use this method. Okay, so we have here our calculator. So we have shift 1, 5 for the distribution probability. We have negative 0.86. So we have 0.1949. Okay? So it depends on the table given. Okay? If there is a certain value, okay? So if there is no value given in the table, automatic use this type of method. Okay? For me, okay? It's much better for you to use this calculator method because sometimes the human error, okay, is present in terms of the traditional way, okay? Because sometimes you may look it wrong, okay? Because sometimes we have mistakes in looking a certain number because it's time consuming, okay? So in order for us to lessen the human error, it's much better for us to use the calculator. Okay? So just be familiarized with the z-table. Okay? It's okay to use the traditional way, but for me as a tip, in order for us to lessen the time of solving, it's much better for you to use the calculator. Okay? Just remember that thing. Okay, guys? Okay. So we have here 0.1949. Okay? Next, we need to solve for the probability of z is greater than negative 1.37. Okay. So we have here. Okay. So based on the negative z-score table, so the probability of z negative 1.37 is 0.853, which is the area shaded in green on the graph. However, we need the probability when z is greater than. Therefore, if the z is greater than, okay, you need to minus it by 1. Okay? You need to minus or you need to subtract the value from 1. Okay? Remember that. So, like in the first example or the given, the z is greater than. Therefore, we need to what? Subtract the value from 1. Okay? So, in this case, the value of our z in terms of negative 1.37 is 0.0853. So, let's verify it. Okay. So, by using the calculator, the stat function, so we have 1. So, 5 So probability is negative 1.37. Okay. So we have here 0.0853. Okay. So like I said earlier, if the given, okay, if the given z is greater than the value or the said value, you need to subtract it from 1. Okay? So in our case, we got a value of negative 137 equal to 0.0853. So we need to subtract 0.0853 from 1. So if we subtract 0.0853 from 1, okay, we have 0.9147 here. Okay? That's so simple about that. Always remember, in terms of these calculations, if the z, okay, if the z is greater than the said number, okay, you need to subtract that said number or said z-score from 1. Okay? Remember that, guys. Again, if the z is greater than, okay, the z is greater than the value, or sorry, the z is greater than the value given, you need to subtract the z-score of that said value from 1. Okay? Because 1 is the total number or the total value of your area under the curve. Okay? So last is we have here. Okay? So it's full screen. So we solved the 3 already. So last is we have the probability of z greater than negative 1.25 but less than but less than 0.37. So let's solve this problem. Okay, so we have 1D. So what is the probability of z greater than negative 1.25? Okay, but less than 0.37. So how we can solve this problem? Okay, so let's use the calculator. So first we have negative 1.35. So we have shift 1, 5, 1. So we shown the process. So we have 0.37. Okay. Sorry. Okay. So we have 0.6443. Okay. So that's the value of the probability of z less than 0.37. Therefore, we will not subtract it from 1 because the value is greater than the z. Okay? Next, if the value is less than z, okay, so we have shift 1, okay, so I have shift 1, shift 1, 5, distribution p. So we have negative 1.25 here. So let's try negative 1.25. So we have 0.1056. Okay? So in order for us to get the value of the certain relationship, okay, or the certain required, so all we need to do is to subtract the value of 0.37 or the z-score of the 0.37 to the value of z-score of negative 1.25. So we have here 0.5387. So that's how simple on how we can solve a certain problem under the standard normal distribution. Always remember, if the z-score, okay, if z is greater than the value, you need to subtract the z-score of that value from 1. Okay? That's how simple is it. Okay? So let's continue. So next is we have the standard normal distribution. Okay? So it is the distribution that occurs in a normal random variable as a mean 0. Like I said earlier, standard normal distribution is happening, okay, if the mean is 0 and standard deviation is equal to 1. So we have here mu is equal to 0, sigma is equal to 1. Okay? So the basic z-score formula for a sample, okay, so we are talking about sample here. Okay? So I think just be familiarized with this formula, but this is more important. Okay? So this formula is more important to remember. Okay? So we have z-score is equal to x minus mean over standard deviation. Okay? So example number 1. So Molly earned a score of 940 on a national achievement test. The mean test score was 850 with a standard deviation of 100. What proportion of students had a higher score than Molly? So assume that test scores are normally distributed. Okay. So let's start with the given. Okay, so we have x is equal to 940. Okay. We have mean is equal to, what's the value? 850. And you have standard deviation is equal to 100. Okay? So for the required, we need to get what? The probability. Okay? Probability is z is greater than 90. Okay? So in order to get the 90, we have this equation. So we have z is equal to x minus mu, or the mean, all over sigma, or the standard deviation. Okay? So for the solution, so we have z, or z-score, is equal to 940 minus 850 over 100. So if we solve this, the value of our z is 0.90. Okay? So probability of z, okay, is greater than 0.90. So why is it greater than? Because what proportion of students had a higher score than Molly? Okay? So in terms of higher, therefore, the value of z is greater than the solved value. Okay? So for the answer, so how we can get this answer? So we will use the calculator. Okay? We don't need the table, we just use the calculator. Okay? So the calculator, it is said here that the value of z is greater than, okay? Therefore, what? We need to, so shift 1. So we have 0.90. Okay. So we have 0.81594. But I said earlier, okay, if z is greater than the said value, you need to what? Subtract the z-score of that said value from 1. So if we have 0.81594, so let's store it to a, okay? So the value of 0.18594 is in a, so we need to subtract it from 1. So I have 1 minus the value which is in a, stored in a. So we have 0.18406, or in simple terms, we have 0.1841. Okay? Hence, okay, 18.41% of students had a higher score than Molly. So that's how we solve a certain standard normal distribution in terms of mean and standard deviation. Just remember, if the value of your z, okay, if the value of your z is greater than the said value, you need to subtract the z-score of that said value from 1. Okay? Just remember that. Example number 2. Okay? So the mean value of the weight of the particular brand of cereal for the past year is 0.297 kilograms, with a standard deviation of 0.024 kilograms. Assuming normal distribution, find the percent of data that falls below the lower specification limit of 0.2742. Okay, so let's solve this. So let's start with the given. Okay. So for the given, we have mean, so we have mu is equal to 0.297 kilograms. Okay. So for the standard deviation, we have 0.024, and for the x is we have 0.2742 kg. So this is also kilograms. So for the required, okay, so for the required, we need to get the value of the probability. Okay? So for the equation, we have z-score is equal to x minus mu all over our standard deviation. Okay? So for the solution, we have z is equal to 0.2742 minus the mean, so we have 0.297 over 0.024. Okay? So z is equal to, we have negative 0.95. Okay. So we have this value of negative 0.95. So based on the problem, assuming normal distribution, find the percent of data that falls below the lower specification limit. Therefore, the probability of z, okay, is less than negative 0.95. Okay, so let's solve this by using the calculator. So we have this value that we need to get the z-score of negative 0.95. Okay, so let's solve this. So the calculator, again, so shift 1, distribution 1 for the probability. We have negative 0.95, sorry. So let's try this. So we have 0.1711. Okay? So based on the problem, okay, we don't need to subtract it from 1 because, okay, so look closely, the z is less than. Okay? Again, if the z is more than or greater than the value, you need to subtract that value or the z-score of that value from 1. But if the value is greater than z, just input it directly in your calculator. Okay? So by using the stat function, so stat function, distribution, probability. Recta, okay? Direct, direct to the point to your calculator, then you have this answer of 0.1711. Okay? Hence, 17.11% falls below the lower specification limit. Example number 3. The mean value of the weight of a particular brand of cereal is 0.297 kilogram. Okay? So with a standard deviation of 0.024, assuming normal distribution, find the data that fall above 0.3738. Okay? So in this case, we solve for the data falls below. In example number 3, we will solve for the data that falls above. Okay? So again, let's start with the givens. So for the given, we have mean is equal to 0.297. So for the standard deviation, we have 0.024. For the x is we have 0.3738. So for the required, we need to get the probability. Okay. So for the equation, we have z is equal to mu or the mean x, sorry. So we have z is equal to x minus mean over the standard deviation. So for the solution, we have z is equal to 0.3738 minus we have 0.297 all over we have 0.024. So our z is equal to 3.2. Wherein, okay, again, if the value of z is greater than the given value, we need to subtract it by 1. Okay. So let's solve this. Okay, so let's use the calculator. So we have 3.2. Sorry. So we have 3.2. So we have P standard, sorry. So we have shift 1 distribution port 1. So 3.2. So we have this 0.991. Okay. So in this case, so in order for us to solve this problem, okay, we need to do is what? Process we need to do? Okay, we need to what? Subtract. No, the step. So let's see if we do this sample. So shift store A. So we stored the value. So you have 1 minus shift alpha A. Okay. So we have 6.9 times 10 raised to negative 4. It's just the same as this. So, like I said earlier, if the value of your z is greater than the said value, okay, subtract the z-score of that value from 1. Okay? So, it's just the same as this. Okay? Example number 4. A large number of tests of line voltage to home residences show a mean of 118.5 volts and a standard deviation of 1.20 volts. Assuming normal distribution, find the percentage of data between 116.1 and 120 volts. Therefore, we have 2x. Okay? So first for the given, so we have mean is equal to 118.5. So for the standard deviation, we have 1.20. So we have x1 is equal to 116.1 and x2 is we have 120 volts. Okay? So for the required, we need to get P is equal to 116.1 Z less than Z greater than Z. So Z is greater than 116.1 but less than 120. So this is the range. Okay. So for the equation, so we have Z is equal to X minus the mean over our standard deviation. So for the solution, let's look in the problem. So we have lower and upper. So we need to solve for the upper. So like I said, we have x1 and x2. So we need to solve for the 2. Okay? So I think we can shift this in this example. So let's denote some solution. So we have x1 or our lower and x2 is our upper. So we need to solve for the upper and the lower. So first, we will solve for the lower. So we have x of 116.1 minus the mean of 118.5 over the value of our standard deviation. So we have negative 2. Okay. Next is for the z upper. So the value of our x2 or our x upper is 120 minus 118.5 over 1.20. So we have 1.25. Therefore, our relationship in terms of this problem is we have probability of z, sorry, the probability of z is greater than negative 2, okay, but less than 1.25. So, how we came up with this value? Okay, so let's have the calculator. Okay, so let's have the calculator. So, we have shift 1. Okay, the first step is we need to get the value of 1.25. Okay, we need to get the z-score of 1.25 because it is greater than z, therefore, direct to the point. Okay, so we have 5, 1. So we have 1.25. So we have 0.89435. Okay, so let's store it to A. So we have A is equal to the value of the z-score of 1.25. Next is we need to get the value of negative 2. So shift stat distribution 1 for the probability. We have negative 2. Okay. So we have 0.02275. So let's store this to B. So the next step is we need to what? Subtract the value. So we have alpha A minus the alpha B is equal to 0.8716. So that's how simple to solve this problem. Okay, so we just need to subtract the values. Okay? Hence, 87.16 falls within the range of 116.1 and 120 volts. Okay? Example number 5. It is required that the mean acid content of batteries manufactured using the acid filling machine is 1250 ml. The standard deviation of the fill volume is known to be 9 ml. In each production run, acid contents in 4 randomly chosen batteries were measured. Find the probability that the sample mean is between 1248 to 1252 ml. Okay, so let's solve this problem. So we have lower and upper limit. So like in this problem, so we have lower and upper x. So we have x1 and x2. Okay, and our mean is equal to 1250 and the standard deviation is equal to 9 ml. Okay, so in the given, so we have x1 is equal to 1252. Okay, and our x2 is equal to 1248. Okay, so our mean is equal to 1250. Our standard deviation is equal to 9 and our n is equal to 4. Okay, so in this problem we will use this formula. Okay, so we will use the second formula here. Okay, okay, so let's solve first the lower value. Okay, so how we can solve this? So x2 or x1 for the lower value, okay, or the lower x bar. So 1252 minus 1250 over our n is standard deviation divided by the square root of, sorry, the sigma, which is equal to 9 divided by our standard deviation is equal to 9 divided by the square root of n, wherein we have square root of 4. So we have 0.444, and from the upper, we just need to use the value of the x upper here. So we have 1248. So we have negative 0.4444. So how we came up with this value? So let's have the calculator. Okay, so shift 1 5. So let's first solve for the value of this 0.4444. Okay, so we have 0.4444. So we have 0.67162. So shift store A. So let's store the value to A. Next is shift stat distribution 1. So we have negative 0.1234. Okay, so we have 0.32838. So let's store this value to B. Okay, so next one is to subtract the values. So we have A minus B. Therefore, we have 0.3433 or 324 here. Okay, so hence 34.33% falls within the range of 1252 and 1248. Okay? Next, we have normal approximation to binomial distribution. So it is often used to solve problems that involve the binomial distribution. Since when n is large, say 100 or more, the calculations are too difficult to do by hand using the binomial distribution. Therefore, we will use this normal approximation. Okay? So, not so important. So, let's focus in this table. So, in order for us to find a certain value, okay, where the probability of x is equal to a, okay, so use this condition. Okay, so if the probability of x is greater or equal to a, use this condition. If the probability of x is greater than a, use this condition. If the probability of x is less than or equal to a, use this condition. If the probability of x is less than a, use this condition. Okay? So for all cases, okay, remember the conditions. Our mean is equal to n times p, and our standard deviation is equal to the square root of n times p times q. Okay, wherein the value of our q is equal to what? 1 minus p. Okay? So if n times p is greater or equal to 5 and n times q is greater or equal to 5. Note, you don't include the value or the exact value of a, so you add and subtract 0.5. Okay, so how we can apply this into the problem. Okay, so let's have an example. A magazine reported that 6% of American drivers read the newspaper while driving. If 300 drivers are selected at random, find the probability that exactly 25 say they read the newspaper while driving. Okay. So, in terms of this problem, we have probability of 6%. So, like I said last time, okay, so if you have percentage, automatic, this is your probability. And you need to what? Convert the percentage. So, you need to convert the percentage into what? Decimal. So, what is the decimal form of 6%? So, we have 0.06. Okay? So, like I said earlier, the Q, that is just 1 minus P. So, we have 1 minus 0.06. Therefore, we have Q is equal to 0.094. And N is the 300. So NP, so let's multiply NP is equal to 8. So we have 0.06 times 300, we have 18. So NQ is equal to 0.94 times 300, we have 282. Okay? So NP is greater or equal than 5 because it is equal to 18. And NQ is greater or equal to 5 because it is equal to 282. Therefore, normal distribution can be used because based on the table, okay, we can use this normal distribution, okay, if n times p is greater or equal to 5 and n times q is greater or equal to 5. So, based on this problem, based on the answers in this problem, we can use the normal distribution because np is greater or equal to 5 because it is equal to 18 and NQ is greater or equal to 5 because it is equal to 282. Therefore, okay, we can use this condition. Okay, so find the probability that exactly is 25. Therefore, if we have this term exactly, it is also equal. Okay, so probability of x is equal to 35. Therefore, okay, if a is equal to x, so based on the problem, exactly, so we will have equal. So we will use this format in terms of normal distribution. Okay, so our a here, okay, so our a is equal to 25. Okay, so therefore, if we arrange the certain, okay, so remember this, okay, so we have P, quantity, A minus 0.5, less than X, okay, less than, X is less than A plus 0.5, so we have here, so this is the A, so 25, so we just need to distribute, or we need to substitute. So we have probability of 25 minus 0.5 less than x less than 25, or the value of a plus 0.5. So that's how we solve a certain normal approximation. Okay? Just remember, in order for us to verify if it is can be used for normal distribution, okay, the value of your NP and the value of your NQ, okay, should be greater or equal to 5. So if this is not greater or equal to 5, you can't use these conditions. Okay? Always remember to read the problem, because if you don't read the problem, okay, you might have a wrong findings. So we have different findings. So for example, you have this we have this exactly. So we will use the equal here. Okay? So just remember the process. So lastly, we have the exponential distribution. Okay? So the exponential distribution is one of the most widely continuous distribution. It is often used to model the time elapsed between events. So the mean arrival rate is given by 1 over v, and the mean interval time is given by b. So it will be shown for the exponential distribution that the mean is equal to the standard deviation. So example, mean is equal to b, and b is equal to sigma. So in other reference, so it is the lapse rate, or the lambda is equal to 1 over b. Okay, so we can understand it if we have problems. So we have the parameters here. So the b, or the beta, is the expected value of x. So f of x is equal to 1 over beta. Okay, 1 over beta times e raised to negative x over beta. So for the cumulative distribution function, so you have function of x is equal to 1 minus e raised to negative x over beta. Okay, so we have this example. So laptops produced by XYZ company last on average 5 years. The lifespan of each laptop follows an exponential distribution. So we need to calculate A to E. So first, we need to calculate the rate parameter. So in order for us to calculate the rate parameter, so we just need to present it. So lambda is equal to 1 over beta. So beta is the expected value of x. So in this case, you have 5. Therefore, we have 1 over 5. Okay. Solution number 1.5. So what is the probability density function? So we just need to present it. So the formula is we have f of x is equal to 1 over beta e raised to negative x over beta. Okay, so in our case, if we substitute the value of beta, it is equal to 5. So we have 1 over 5 multiplied by e raised to negative x over 5. So no need to solve or to simplify, just input the value. Okay? So solution 1.c. So what is the probability that the laptop lasts less than 3 years? So in terms of this, so we have this probability is equal to x less than 3. Therefore, we can use this integral, like I said. So we have integral, so the lower limit is 0 and the upper limit is 3. So enter the formula, so we have 1 over 5. Okay, so e raised to negative x over 5 dx. Okay, so the probability is equal to, so how we can solve this? Use the integral in the calculator. Okay, so let's show the integral. Okay, so let's go back to our mode for the composition. So in order for us to solve this problem, so I have shift, so we have integral here. Okay, so that's correct. So we have 0 for the lower limit and 3 for the upper limit. Then just enter the formula. So we have 1 over 5. Okay, quantity, we have e. So where's the e? So we have e raised to, okay, e raised to negative, we have x, so alpha x over 5. Okay, so we have 0.4512. So that's how we solve a certain exponential distribution problem. Okay, so for this condition. Next, for solution 1.d. Okay, So what is the probability that a laptop lasts more than 10 years? Therefore, we have a certain range of 0 to 1. Okay? So we have this condition. So we have the lower limit of 0, the upper limit of 10. So how we can solve this? So let's go back to the calculator. Okay, so clear. So we have here 0 is the lower limit, 10 is the upper limit. Okay. So we have 1 over 5 multiplied by e. So let's just have this e raised to, sorry. So we have negative x over 5. So let's close the parenthesis. So we have here, is it correct? Okay, so if the x is greater than, okay, we need to subtract, okay? So alpha a, sorry, oh my god, back. Okay, so let's try it again. So we have, I cancelled it. So we have 0, 10, and it is what? You have 1 over 5 multiplied by shift e, where's the e here, raised to negative x over 5. Okay. Okay, so we have this value, so shift store a, and we need to subtract it from 1. So 1 minus alpha a. So we have 0.135335 and so on. So we have this value. Okay? So for the last required here, so what is the probability that the laptop lasts between 4 to 7 years? So we have this limit. So basic. So we need to integrate it. Okay? So how we can show this? So let's have the calculator. Okay? So we have integral of 4 to the 7. Okay? So we have 1 over 5 multiplied by shift raised to negative. Oh, we have x, alpha x over 5. Therefore, we have 0.2027. Okay? So that's how we solve a certain problem under exponential distribution. Okay? So that's all for our part 2 of our discussion. Okay, so if you have any questions, clarifications, and inputs, don't hesitate to message me in Teams. Okay? So that's all for Module 2.2. So your activities and quizzes will be uploaded next week. So next meeting, I will upload the part 1 and the part 2 of our Module 2.3. So thank you everyone, and I hope you learned something from this lesson, and see you around in the next meeting. Thank you everyone and have a good day.